Hi everyone. So in this video, we're going to go ahead and discuss kinetic energy, which is the energy of motion. So let's go ahead and get started. Okay, so as I said, kinetic energy relates to the motion or when objects are moving. And we can calculate kinetic energy using the equation KE, kinetic energy, is equal to 1/2 times the mass times the velocity squared. So we take the value for the velocity and we square it. And then we take that times the mass, and we take 1/2 of that value to find the kinetic energy. So the important thing to notice here is that the kinetic energy is going to depend more on the velocity than the mass of the object. That is because we just take the mass, but we square the velocity. Okay, so let's go ahead and calculate an example of this. What is the kinetic energy of a cheetah that has a mass of 44 kilograms and is running at 30 meters per second, so really fast? So we first need to think about our equations. So we're going to use that 1/2 times mass times the velocity squared. And our mass for this problem is 44 kilograms. Our velocity is going to be the 30 meters per second. So then we're going to go ahead and substitute those values into our equation. So 1/2 times 44 times the 30. And remember, we only square the 30, nothing else in this equation. So 1/2 times 44 times 900, which is 30 squared. So if we multiply all those things together, we get 19,800, and then our unit for energy, remember, is always joules, or J. So the cheetah is going to have 19,800 joules of energy. Okay, so let's do a different calculation. What is the kinetic energy of a deer with a mass of 44 kilograms running at 15 meters per second? So again, we use that same equation. The mass is the same, but the velocity is different in this case. So as I go ahead and plug that into my equation, I get 1/2 times the mass times 15 squared. And again, I'm just squaring the velocity, nothing else gets squared. So 1/2 times 44 kilograms times 15 squared, which is 225. So if I go ahead and put that in my calculator, the product of those things is 4,950. So if we compare that to the kinetic energy of the cheetah, which was over 19,000, changing that velocity makes a big difference on the kinetic energy, which should seem reasonable because kinetic energy is all about how fast the object is moving. So again, just to summarize, even though the cheetah and the deer had the same mass, the deer was moving significantly slower. Therefore, its velocity was smaller and its kinetic energy was also smaller. Okay, so I hope this helps. If you have any questions, please let me know. Otherwise, make sure you're identifying your variables, you're plugging them in, and only square the velocity when you do those calculations. Otherwise, have a great day, everyone. I'll see you later. Bye.